Welcome everybody. It's quite late already, so let's focus on continuous patch and security assessment of Inspec. So first questions first, like who knows what Inspec is? We need to improve that. So we've been talking a lot about CI/CD pipelines, and we have really been focusing on anything regarding like code to a build. So now, like, this is not all, right? So we deploy it into an infrastructure. So we deploy it into something that actually runs our application. So how are we actually sure that everything that runs in our infrastructure is configured according to our plan? So that's what we are talking about today. So think about Inspec focusing more on infrastructure when you deploy your application instead of like being as part of like code checking tool. So I'm in the industry for about like 8 to 10 years. I started at Deutsche Telekom and SAP, and we really started with OpenStack, automating OpenStack, do it all in an automated way. But if you're like working for a big telco, you have big regulations as well. So you have like those paper documents, hundreds of pages, how you have to harden your server, which is neat, but it's not really cool if you're starting a cloud environment where you really want to scale quick, and so that's not working out. So we figured there's a gap, and we started a company called VolcanoStack, which just really was focusing on how can I automate compliance requirements, which is essentially about Inspec. And our company got acquired by Chef, and I'm heading the complete environment engineering of that toolkit now. So when we talk about security, we also need to talk about compliance, and we need to be remembered, like, why is that even important? And we've seen a couple of things happening in the past where big companies have not behaved in a good way, as we consider a good way. So this is still happening. So there are like security risks all over, but then we see like there's a loophole. There's exploration, there's a scandal, and there's regulation. So we can all complain about regulations, but essentially they are intended to improve the greater good. Still, like mostly it's a lot of paper documents, and it's really hard to apply those regulations in your environment. So people are normally not really complaining about the regulation, but how difficult it is to apply those regulations. So let's see how we can make this better, but just to give you an overview, there are a lot. So there are a lot of regulations, and if you're like a multinational company, it's very likely that you have to cover multiple at the same point in time, even if they have an overlap. So when we talk about compliance too, we need to understand that compliance and security are not necessarily the same thing. So like compliance essentially is the wording of, okay, this is the expected state. So this is something that I define that should be right. But saying my user account name is all lowercase is also a compliance rule, but it's not necessarily a security rule. But if compliance is done right, it's necessarily like it should improve like its security as well. So we quickly go over it, you know it, like there are like the basic vulnerabilities are well known. And so we see two aspects here as well, which is essentially like security misconfiguration and also like components with known vulnerabilities. And this applies for operating systems as well. This applies for basic applications like Tomcat, web server, operating systems. So it's really well known. So it's not that we don't understand that problem, but it's really difficult still, right? Would you agree? And like, let's take a look at those documents. So there are like security hardening guides available for decades, really. So that is, try to understand like, how long does it take you to verify those documents on your server? So are you compliant? Of course, good. That's good. So, but we, like, as a coder, right, we know this. We want to automate, we want to write quick, we want to run it in our CI/CD pipeline. And this is really what we figured, like there's a difference between how every part of the pipeline, they all work together, but they talk different languages. Difficult. On top of that, we have, like in the past, we had an app we deployed on one server, great, but now we have more servers, so like manual testing is really difficult. It scales even further, so now we have more servers, great, so now we need to check all those. And like we figured already, like DevOps is improving the speed, like how fast we deploy. Then we have cloud is growing, and we have IoT, which like the number of devices is now growing as well. So that's a challenge, and to apply those rules across over, it's really difficult. So I will talk now like about the solution. So we talked about the problem, we've seen it, and we talked about how can we solve that. And I use the term compliance-driven infrastructure because I want to get those requirements really as early as possible in the pipeline, as we've talked like today already, security as early as possible in the pipeline. So in this specific example, I will give you two open source projects, Inspec and the DevSec project, that helps you to run those guidelines quickly on your server. So what is Inspec? So Inspec is really a tool that turns your infrastructure testing, compliance, and security requirements into code. And we have a look in now how this works. We take a really simple example. In this case, it's just, hey, let's verify that we're using SSH version 2. Sounds easy, right? So this is how you do it normally. You run a command, you run grep, looks great. So this is really cool if you're like a developer, you understand regular expressions. It's working out well with my bash script, but how do you share that in your organization? So we came up with a language that allows you to say, hey, I test a requirement. So that's a final state. So in this case, I'm saying the SSH config protocol should be set compared to 2. So it's now different. I don't use any regular expressions anymore. So I just define it. And on top of that, I can define metadata to that as well. So I have an impact, criticality, title, description. We have additional options to add tags, reference. So we are like working with like major like US government agencies, and they use it because they have so many different like cross references, and you want to attach that to the code as well. So, so we've talked a little bit. So the cool thing is about this test, you can run it locally and you can run it remotely. You can run it against the like SSH, WinRM, and the Docker container. And we quickly have a look at how that works. So we have here, we just started a fresh Docker container. Run d and bash. All right, so container's up, so you trust me that this is a new container. So then I say, I have a quick test in here, trials, let's have a look. So that is just test, oh, sorry, good, thank you. So yeah, so, but still, yeah, here's the fresh Docker container. So here I have a simple test that is just saying, hey, is this package installed? And I say inspec, exec, trials, as package. And now I target the Docker container. So it's connecting remotely. I have not installed anything into that container. So that's completely remote. So I can do that locally and remotely. So that's great. So I can now test my infrastructure. So this is not like only focusing on a single operating system. We cover like all major operating systems. I just figured like Ubuntu, we of course support Ubuntu 16.04. We also support Windows 2016 and Windows Nano. So that's all included. So it should be, you should be able to cover your operating system. You have a lot of out-of-the-box resources to cover like basic configuration ranging from core operating system tasks like users, packages, groups, databases. So that gives you a really like easy start to verify what is there. Since it's all available as a separate thing, like you're not depending on a DevOps tool, but you can easily combine it with Chef, Puppet, Ansible, Docker. But even if you have a manually deployed server, and we have a couple of companies using it for AIX infrastructure, for example, banks in specific. So they have a lot of those servers running, and they can now use this tool to remotely verify their servers, and they are normally really in a restricted environment. So that's pretty neat. So now we've seen those requirements before, and now we need to translate those to Inspec. And this is giving you an idea, like here we see a requirement from the text translated to code. So we can now attach the title, description, and all this can be attached to the code, which makes it really easy to also visualize it later on. So now assume you have a test, like hundreds of tests, CIS benchmark. Who knows CIS benchmarks? Great. So those benchmarks, who's agreeing with all rules of the CIS benchmarks? Okay, so we've seen a lot of companies disagreeing with that. So the challenge with that is that you have to manage that, right? So if CIS is coming up with a new baseline, like now you need to take up your Jira, or you take your Markdown file where you've managed your overlay and where you disagree, and update it to the latest version. So what we do instead in Inspec, we provide the capability to say, I inherit a profile. So in this case, I can take the CIS level 1 profile, for example, I can inherit it, and I can say I disagree with a couple of rules. And this is fine. So I can just agree inside the organization and I make it part of the code as well. So that means like you're only managing the overlay. When anything changes in the upstream profile, your profile is taking that into consideration as well. And then normally you have multiple environments where you also say you want to differ, and that you can put this in multiple stages. So we see a baseline in a second, so that you can talk about it as well. And we talk about now content, right? So I gave you an idea of how that tool works, a really quick overview. And we now talk about the content because like what is the tool value if there's no content that you can just use. So we talk about the DevSec project, and it comes with a couple of baselines like for Linux, for Windows, and also the patching baseline for Linux and Windows. So that is pretty neat, and we can just use that. So we've just started the Docker container, you've seen it. And we have here the project, and we have, like, let's look for the baseline. Oh yeah, thank you. This is confusing. So here, like this is DevSec project. It's github.com/devsec. And we, for example, look for a Linux baseline. And here we have, so it's a simple ruling. A number of controls are included in here. So you can look those up. I have no time to explain this in detail now. But what we can do now is we just like copy over like this line. I can say, okay, Inspec, instead of the simple Ruby file, I'm just running the whole baseline against that Docker container. So it's downloading this baseline and running it against the remote container. So now it's running. You will see in a second like something, boom. So now we have a response. So in this case, like kernel parameters are, like this is Docker, but so this can be easily deployed to any other environment as well. So the same thing works for Windows as well. And so I think I show you quickly the patch baseline. So we have a patch baseline as well. It's Linux patch baseline, we download it from GitHub and we run it against that container. So it's a freshly started Ubuntu container. It's maybe cached a couple of days ago. Let's see if our packages are up to date. So now it's there. So we see we have a couple of packages not up to date. So it's just like you can run it open source, and you see immediately that there are in your container, or even if it's like not a container, it could be a VM, you see the result. So now as part of an organization, you really want to manage that across like multiple things. So in this case, for example, you want to have a company profile. So that's now even a bigger scope, right? Oh. So company profile. So that means like as a company, you normally have multiple operating systems. You have maybe Windows and Linux. You want to tie those together. And you want to distribute just one profile to be run everywhere. So we've seen now like a Linux baseline is an amount of tasks composed in a baseline. The same for Windows. And we can now define a meter profile that is aggregating multiple profiles. So the advantage here is that with Inspec, you can define those and you can make simple baselines for specific components. So you can use SSH as a component. You can say my application is a component. So you make individual component, baseline for individual components. So that makes it really manageable, and you can focus a baseline on one specific component, and you can manage those in GitHub. But like now you get like multiple like baselines, and it's still like difficult to share those around. And that's why we came up with the Meta profile. And this is how it works. So you can say in your Meta profile, I include controls, and I can also like, this is how you manage your overlays too. Like I can skip controls, I can change controls. And this is really powerful because it allows you to manage everything. And I have an example available. So this is I call it the Acme profile. So that profile is essentially for Acme Inc. And here you see, I just pull in a couple of like profiles. I say I depend on the patch profile and the base Linux profile, Windows, and SSL, for example. So that makes it easy to use that everywhere. So now let's have a look how we include that. For example, hardening. I just say, hey, just want to include like every role from that baseline. Of course, we can disagree. Same applies for patching. So now let's run this baseline on the same Docker container. So as you've seen, you have Windows and Linux things mixed. And obviously, we want to minimize false positives. So like, hey, when I run Windows stuff on Linux, is that wrong or right? So let's see. So I'm here. So we have the Docker container running here. Okay. So I cached that locally, so it's a little bit quicker. Okay, now we run the aggregation on that Docker container. So that means like Windows patch profile, Windows hardening, Linux hardening. So they all run now against the same container. That's difficult on that. Yeah, so it's not optimal to read, but I like what you see here, like multiple profiles have been executed. So this is the patching, you've seen it. And here's the Windows patch baseline, for example. And you see that all those tasks have been skipped. So Inspec allows you to define an only if condition, for example, that says only run those controls, like if you're on Windows. And for those baselines, they are implicitly there because like the Linux baseline is saying in the metadata, I'm only supporting Linux. So then Inspec knows, hey, if you run this against Windows, I don't need to execute that because like it's not intended to run on those. So that means like you really get a better overview across your infrastructure by saying, hey, this does not apply to you. And why is that important? The same can be applied to an application. So let's assume you do this for Apache. and you assume you don't have Apache installed on your machine, but then accidentally, like for a quick fix, you need Apache to be installed, and the administrator is logging in, installing Apache to solve the business need, and then now you need to implement Apache hardening as well. So then if you do that, like you run the next scan, immediately it will figure out Apache is installed, and then boom, like you have all the tests running without like additional like managing. So to sum this up, we have like this allows you to perceive compliance not as a blocker anymore and as late game in your CI/CD pipeline. We've automated it, so the whole baselines that we have are now part of a code. So they are managed in Git, like the same as you do with everything else, and then you can deploy this everywhere. Every developer can just download Inspec, run those baselines, and see the result. So that's a lot better. And with having the additional descriptions attached, you really can see what's going on. But you can attach references like web links, and this makes it really easy to work with that. So instead of like putting it like as the latest stage in your infrastructure, we've seen companies using those baseline to verify existing manually deployed servers. Then they figure out, oh, we are not complying with our rules. And then they start building automation. So luckily, the DevSec project is shipping hardening cookbooks for Chef, Puppet modules, and also Ansible modules for those baselines. So it's really easy to get started. So you start normally locally, you test it in your environment, you put this in your CI/CD pipeline, remediate, you verify again, and you can now make it a continuous cycle. So that's why I call it continuous compliance. So just to sum up what we have seen Inspec as a tool to test and manage complex testing and compliance rules. We have seen content, the DevSec hardening framework, how you can use it. And those combined really enable you today to just get started, run it on your server and see what's going on. Further resources are available. It's inspec.io where you can download it. I have stickers with me, so in case you need one. We have also like the DevSec project providing you with all the baselines, and that should get you started. Please join Inspec, help to cover more. Also join the DevSec project, contribute there. So it's all open source, so we are all together on this to improve the security of our infrastructure. Thank you very much, and I think we have a couple of minutes for questions. Yeah.
Where do you keep the non-compliance of vulnerability management software, or what happens to the non-compliance?
So you mean like when a test fails, where it feeds to? So there are a couple of possibilities. So for example, you can put this into Jenkins. There's a Jenkins plugin that like can output JUnit on command line. But we have also like Chef as a company is providing commercial tooling around that. So like there's a tooling available where you can show like every fail control, you can manage it. That is doing all the integration inside any commercial tool. Okay, yeah. Mm-hmm. That is a very good question. So they are not defined. So right now, this is implemented in the Linux patch baseline, and we implemented it for various Linux systems like Ubuntu, Red Hat right now. So this is using the information that the operating system has available. So for Windows, it's using Windows Update Services. And for CentOS, it's RPM. Essentially, you can also, like we haven't done this right now here open source, but you can also ask a mirror to say, so we do this with a couple of other companies who maintain this, so because we're not a company that is maintaining it. So they are like, they are doing this, so reading the packages ask the API, get the response, and return this then as a result. So it really depends on how you want to implement it. The version is really asking the operating system, but if you're using an old mirror, for example, like you still have troubles with that approach. So you like the ultimate goal, and this is where we want to get there, that you have the local state, but also like an upstream perspective on that. Yeah, very good question. Any other question? Yeah.
How do you gather the information together from the system? How do you see which way the package is there?
So we can go into technical details. So we have multiple, we have an abstraction built into Inspec. So that means like we essentially from Inspec perspective, we only know two things. We can transfer a file, so load a file or run a command. So that's the only, that's the interface. And then we have multiple backend information, backend implementations, how we call it. So one backend is SSH, one other is local, another is Docker, for example. So there that's extendable. We could potentially add more. We could implement Telnet if we want to, but we don't want. So that's the abstraction, and then we have written all the logic into an Inspec resource. This is how we call it, and this is in Inspec, GitHub Inspec. Here we have lib resources, and in this case, for example, let's take the package resource. Oh yeah, sorry. So here, this is Inspec, lib resources, and let's take a look into the package resource. So here you see, like we have multiple package managers implemented, and based on the, let's take the DApp package manager, and here we call out to dpkg, get the response, parse the results, and make it available in a JSON format. So that you can deal with this. And I can give you like a quick example. So Inspec has also a cool shell to play with that. So here we have help resources, for example, gives you everything, and we can say Docker, give me all containers. Entries. Cool. So I can say Docker, where give me all containers, where image is equal to Ubuntu. So, okay, entries. So, okay, now we want to make sure that we have only the running ones. So here's really, this is really also covering internally. We have really parsed the data, we have it available, we have a query engine essentially, so which allows you to write really complicated compliance rules with that. And we run CAS baselines on it, we run PCI baselines on it, so that we're covering a lot, and we work with MITRE that has they challenged us a lot with those tests. So this is really there's a really good engine underneath, and it's really easy to extend as well. So we don't expect everybody to contribute this stuff to our open source project, but instead our we call it Inspec profile. You can have custom resources included there as well. For example, if you have a homegrown application, you want to write tests for that, you can do that with an Inspec profile. In this case, take a look on the Inspec IO page. We have documentation here, and yeah, talk about a profile, and this is giving you a good overview about how this works and how you can extend this. And so yeah, I cannot cover this here, but should give you a good hint. Anything else? Okay. Yeah, PCI is a very difficult one for sure. You cannot cover all controls for sure. So right now, Inspec is not optimized to do the manual querying, the manual questions. So it's really focusing on anything that you can automate. So there you can cover like rules for like system hardening, for TLS version 1.2 migration, for example. So for example, this is maybe interesting. There's an SSL baseline available. So in case you need to implement the TLS version 1.2 migration for PCI, take this profile and well, you can run it against the server and should give you a good hint of like what's, if you've migrated all your ciphers already. Yep.
Which processes or use cases do trigger a scan?
So
is it like a build or an ongoing scan, or what do your customers do?
So Inspec by itself is just a command line tool. So you can do whatever you like. In this case, let's say Inspec, I just execute a profile, simple profile, exec profile, and I can say format JSON, for example, I type it in JQ, and then you get a JSON output of that result. So that makes it really easy to embed it everywhere. So we use, as Chef, we use Inspec as the core engine for Chef compliance and Chef Automate. This is really, we use the same technique. So there's nothing else that we add on top. So you can use that as well. You can just use the JSON, pipe it somewhere. Like if you want to, I know a couple of companies pipe it to Splunk, for example. So yeah, you can transform the JSON output as you like. Okay. Make sure you pick up some stickers with me, so I don't want to bring them home. Thank you very much.